All right, let's see if I can be smart enough to do this. I doubt it. So I tested positive for COVID at school when I came in this morning. So they made me go home. Super excited about that. Some of you are probably awesome at this. As far as I know, we're still going to quiz tomorrow. I'll probably make it like an online quizzes, like I said in my Schoology update. That way, whether I have a sub or not, you can access and get her done, and then we can just move on from this crazy week. But I wanted to make sure that I did some more teaching in case some of you are lost and confused since I'm not there to help, which is problematic. I'm trying to do the split screen, which is marginally successful, but I do have a filled in unit circle, and I did put it into the filled in notes so you can use it as well rather than having to fill one in yourself all the time. One thing we have not talked a lot about is tangents and the ones where you have to flip things over. So I want to go through what I'm going to do on the worksheet is the left side, the odds. And that way, hopefully those of you who need more help can feel more confident. And those of you who don't, get free answers. All right, so this is tangent. And if you look in your notes, tangent is, okay, so my pen's not working. So far it's going well. So tangent is the sine over the cosine or the y over the x. And we haven't done any like that. I think all the other worksheets and such have been sines or cosines. So if tangent's going to equal the y over the x, I need to go to the unit that they gave me. So this question is saying, what's the tangent at 60 degrees? So getting to 60 degrees is not that hard. It's right up here in the corner. And my x is a half and my y is root 3 over 2. So if I put my y, which is root 3 over 2, over my x, which is a half, I get what's called a stacked fraction. And to do stacked fractions, which is actually something you do quite a lot in calc, so you want to be able to do that, you take the top and you multiply by the reciprocal, meaning you multiply by the bottom flipped over. So in this case, these cancel, and my answer would be that the tangent at 60 is root 3. And you can see on here that I actually wrote my tangents in. I have a tangent written at each spot, if you can find it. So I do tangent, what I call tangent boxes, meaning like you can see this kind of turquoisey blue. Everything that is in a corner of the turquoisey blue color has a tangent value of root 3. It's just a question of whether it's positive or negative depending on the quadrant. You can see here all these green corners have 1 as their tangent value, positive or negative, and that's because in those corners I have these coordinates. And so if I was putting the y over the x, I'd end up with root 2 over 2 over root 2 over 2. And I'd have something over itself, which cancels out or reduces to be 1. And then the purple box, they're all going to be root 3 over 3's. And I have that in each of the corners. I didn't write it here. Oh, here it is for this guy. And again, they just change positive, negative as you go around the unit circle. And we've put the different positive or negative signs on our notes in the past as well. So anyway, this is back to something easier. This is asking for the sine, which is the y value at 90. So it wants the sine at 90. I go to the top of my circle. I look at my coordinates, and I decide that I'm going to use the y, which is 1. Okay, so then I'm going to keep... Sorry, I was pulling something else up on my other computer. Got a lot going on. Cosine is x, and again, 90. So it's asking for the x value at 90. I'm looking up there right now. I can see that the x value at the top of the circle, or 90 degrees, is 0. So my cosine value is also 0. All right, how about 7? So 135 is where I'm going. So it's asking for the cosine of 135. You can tell, like here, the cosine or x is negative, the y is positive, and so my cosine should be a negative number when I look it up. So I look over here, I find 135, and I'm looking for my cosine x, which is this guy. So just like I expected, it's a negative because that's how you get into quadrant 2, is to have a negative x. All right, 270. This is asking for the cosine at 270. So bottom of the circle. And again, cosine is x. So if I go to the bottom of the circle and I look for 270, which is also 3 pi halves, and I look for the cosine or x value, I see that there is a 0 there as well. So I know that these worksheets look long, but once you get the hang of them, they should go pretty quickly. Where are you going? What are you finding? So this question 11 is actually the exact same question as the one right above. This was asking for the cosine at 270, so is this. So my answer is still 0. Now, inevitably, when you hit radians, it becomes more complicated because now you have to really think about where to find that. Keeping in mind that pi fourths are always in the middle, I can see that over here at 315 degrees, I have 7 pi fourths on my filled in unit circle. Cotangent, okay, this is tricky, is asking for the x over y. Since tangent's y over x and cotangent flips that over, it's asking me to take at that 7 pi fourths the x, which is right here, and put it over the y. So I'm going to put my x over my y. And like I said above, stacked fractions mean you take the top as is times the reciprocal of the bottom. And in this case, you guys, all of these cancel, and the only thing that's left is that negative sign. So when everything cancels out, it's not 0, it's a 1. But since you have a negative sign floating around in there, that is actually going to be a negative 1. If you're using this circle and the tangent values are already filled in, you're right here, so your tangent value is a negative 1. The other way to do that is think, okay, well, if the tangent's negative 1, I can flip that over. Well, flipping over a negative 1, since it's currently negative 1 over 1, would turn into 1 over negative 1, which still is negative 1. So if you have the tangent value in front of you, you can flip it over, or you have to do the, hang on. Sorry, you can flip over the coordinates. Okay, cosecant. So think about that. Cosecant flips over the sine, so it flips over the y. So let's find the y at this value and then flip it over. So 225 is right here. So at 225, my sine is root 2 over 2. And so this is my sine value that I need to flip to get the cosecant. So if I flip it, it looks like that. But then I have to rationalize it. So I get 2 root 2 over 2. But since these two are both on the outside, they cancel. So when it's all said and done, my answer, and if you look at the key, just looks like a nice clean root 2. But for full credit, like, you're not going to be able to do that in your head, and that's not a challenge. That's just kind of a fact. I want you to kind of show, like what I'm doing here, you would show as your work. Cosecant, a thinker again. So that's going to be the sine or the y that we need to flip over at 90 degrees. 90 degrees is at the top of the circle. So the y value is a 1. Well, 1 is over 1, and when you flip it over, it's still going to be 1 over 1. And so my value for the cosecant at 90 would be 1. 19 is easier in that it's straight up asking for y. It's a little tricky because it's radians, but pi over 4 has to be in the middle because it's over 4. And I can see it right here. So I'm looking for the y value there. And since it's in the middle, I expect it to be a root 2 over 2 of some sort, positive or negative, because the middles are always that way. So now this next one's challenging in a different way, and this is part of what I was trying to go into in the notes video. 13 over 6, and it's negative, and it's tangent. So I can use my tangent boxes. Since they're written on here, I can use the value, but I still have to figure out where I am. So first of all, negative means I'm going the opposite direction. But think about being over 6. If this end has to be pi and 6 is on the bottom, then you need a 6 on top. So that corner or that side of the circle is 6 pi over 6. All the way around, since I need it to be equal to 2 pi, would have to be like this, since I was using 6's on the bottom. Because this would reduce to pi, this would reduce to 2 pi. The reason that helps me is to figure out where I am. So I'm going negative. So I'm going all the way around, because all the way around is 12, and this is bigger than 12. So I'd go all the way around. That would be 12 pi over 6. So if you think, okay, 13 pi over 6 is how far I'm going, once around is 12 pi over 6. That means I have 1 pi over 6 left to go. So I'm going to go 1 pi over 6 past that full circle. And I'm going in the negative direction. So if I do that, I end up going all the way around and then 1 extra pi over 6, which puts me right here. Get rid of that for later. Okay, so I'm at this spot. And I am finding let me get rid of all this other stuff so there's room. So now that I've located my spot, I'm looking for my y over x. I do have it marked as the negative root 3 over 3, so I already know that's my answer. But for those of you who are trying to figure out where that came from, it would have been from my y, which is negative 1/2, over my x, which is root 3 over 2. I take the top multiplied by the reciprocal of the bottom. 2's cancel. So I would be at negative 1 over root 3. I'd have to rationalize. So then I'd be at negative root 3 over 3. So there's kind of a lot of steps involved, but again, I do have, and I don't care if you use the tangent values that are already drawn in. So once you locate it, you can go ahead and use this tangent value that you see, the negative root 3 over 3. All right, 990, are you kidding me? Okay, so for 990, I got to just figure out where I'm at. So an easy way to do this is to just think, how many times am I going around? And it's so much easier with degrees than it is with radians. So you guys know that all the way around is 360. So if I were to take away 1 trip around, I'd be at 630. If I take away another trip around, then I'm going to be at 270. And that's where I stop. And the reason I stop there is that's in the circle. Like now I can find it. So I would have gone all the way around, then all the way around again, and then 270. But it doesn't matter how many times I went around. It just matters that I stopped at the bottom of the circle. That's my location. So I go to that location, and it's asking for the cosine, which is the x. So looking on my unit circle, the answer is 0. Cosecant. Okay, that is going to require me to flip over the sine or the y value, but I first have to figure out where I'm at. 5 pi over 6 is normally right here, whoops, right here, but it's negative. So I go the same distance the other way. So here I started at my start point and I went until I got to the line right before 180. I'm going to do the same thing but the other direction because that's negative 5 pi over 6. So that puts me right here. That's what they want me to look at. So I'm going to go ahead and look at that spot and figure out what is the sine. Then I'll flip it over to get my cosecant. So I'm right here, and my sine or y value is negative 1/2. Okay, so that would have been my sine, but I need to flip it over, and I would have 2 over negative 1. So my answer to the cosecant at that location is negative 2. 29 pi over 6. Boo. All right, think about it. Again, all the way around the circle, when you are using sixths, would be 12 pi over 6. So just like we did up here with the degrees, let's start with what we've got, which is 29 pi over 6. And let's subtract trips around the circle, just like we did with the 360. This is going to turn into 17 pi over 6. That's not on the circle, so I take away another trip around, just like up here. Our first trip around landed us at 630. That wasn't enough, so we had to subtract another 360. Doing that again. We're just going around the circle more than once. So we're taking away 12 pi over 6 each time. But 17 minus 12 puts me at 5 pi over 6. That's good. I can find that. That's right here on my unit circle. Now, what are they looking for? Sine. So y. So now that I know where I am, I just look at my y value, which is 1/2. All right. Last one for me is this cosine. That'll be easy. I'll just get the x. I just got to figure out where I am. So pi over 2. You can see at the top of the circle that pi over 2 is 90 degrees. So every chunk of 90 degrees is a pi halves. So you can think of this a couple different ways, however it's easiest. And you go in negative. So let's start here. If we went, and we're counting by 90 degrees, so that's easy because it's the axes. So this would be negative 1, 2, 3 pi halves. All the way around would be 4 pi halves because, again, that would reduce to 2 pi. So then 5, 6, 7, all the way around again is 8, 9, 10, 11. So I end facing upward. If that's confusing, you can also do what we've been doing. 11 pi over 2. If I take away one trip around, which is 4 pi over 2, because that would reduce to 2 pi, now I'm at 7. Still not on the circle. So I take away another. Okay, well now I'm at 3. But the problem is this one was negative. So I'd be going my 3 pi halves in a negative direction and still going to land at the top. So whatever way makes the most sense to you to figure out that you are at the top of the circle and they are looking for the x, so your answer is 0. Okay, so what is the quiz going to be like? Well, if there's a human, adult human giving the test, you'll have a quadrant that you're going to fill in on a sheet of paper, meaning if they gave you the first quadrant, you would have to be able to put in all the information for this much of the circle, which is going to be the coordinates, the radians, and the degrees. You don't have to put in the tangents. If there isn't a human, you'll just do an online quizzes. Even if there is a human, after you do that little paper quadrant, you'll do an online quizzes in their presence. But the idea is just for me to get some clue of who knows what's going on. Now, the answers to this other half are still in Schoology. I just wanted to make sure you saw how to do them in case you were struggling. Thanks, guys. Can't wait to see you. Bye.